So in this lesson, we're going to be talking about a new concept that we haven't actually directly talked about, but we saw in the lab. And that's when we're dealing with a chemical reaction rather than just talking about how much product or how much reactant is formed or what the identity of each of those is by chemical reactions. We're going to be talking about the energy that's involved in those chemical reactions. Now, in a chemical reaction, heat can either be, or energy can either be released or it can be absorbed. Now, if it's released, what that means is that you have an exothermic reaction, and what you would feel if you felt that reaction would be heat. It would feel hot. If it's an endothermic reaction, what that means is that energy is being absorbed. And so your delta H, which is your heat, if it's exothermic, is going to be negative because that heat is being released, while if it's endothermic, heat would be positive because it's being absorbed. And so what we're doing here for this is just a very brief introduction to thermodynamics. What we're going to do is say, all right, well, I have a reaction. How much heat is either going to be released or absorbed based on how much reactant I start with. So in this example problem, I give you 5.0 grams of H2, and so that's your given. And what I'm asking you is how much heat will be released. Well, this is going to use this first reaction on the left-hand side. H2 plus Cl2 gives you 2HCl plus your heat. Now, notice your heat, your delta H, is negative 185 kilojoules, but it's kilojoules per mole. So for every 1 mole of hydrogen gas that is used, you're going to release 185 kilojoules. So what I need to do, if I know I have 5 grams of hydrogen, I first need to convert that into moles. And so I'm going to put grams on bottom, moles up top, and I plug in the molar mass of H2. So now I'm in moles of H2. And now I can use the fact that there are 185 kilojoules per mole as another conversion factor, so times negative 185 kilojoules for every 1 mole, in order to then multiply out and divide, and I find that 460 kilojoules is released, or negative 460 kilojoules is involved. And so for these problems, it's very similar to the other stoichiometry problems you have, except you have one new conversion factor, which is the heat, which is kilojoules per mole.